Hello, this is Mr. Holly, and today we'll be looking at Lesson 7, the addition and subtraction of rational numbers. What this means is that we are going to begin to include fractions and decimals into our addition and subtraction work. You have seen this a little bit so far, but this is going to be exclusively problems dealing with fractions and decimals. Everything that we do today is stuff that you have already learned. You already know about fractions, you already know about decimals, you already know about addition and subtraction of positive and negative rational numbers. Today we're just putting all those pieces together, and it can be a little challenging, so we're going to use some diagrams and we're going to try to walk through it together. Okay, exercise 1, and this is something for you to try at home. Like, you're just going to try this one on your own and see if we can jump in, how it feels. Okay? A 7th grader's birthday is today, and she is 12 years old. How old was she 3.5 years ago? So what I want you to do is pause the video and write an equation and use a number line to model your answer. So go ahead, just pause the video and give that a shot on your own. Okay, now that you're back, let's go ahead and write an equation. And in my mind, that equation would be she is 12, that's a positive 12. 3.5 years ago would be like a negative 3 1/2. So that's 12 plus negative 3 1/2. Put that on a number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Barely fit those in on there. Okay, so 12. And then I need to add a 3 1/2 here. It's negative, so we're going to the left. So I'm going to go back 1, 2, 3 1/2 spaces. So let's make sure we have these labeled. 11, 10, 9, 8. And you can see that this arrow stops halfway between the 8 and the 9. And what that means is she would be 8.5 years old. And that's how we would go about doing that problem. Example 1 actually is that problem. So it's the same idea here. Place the tail of the arrow on 12. So we're drawing an arrow, comes to 12, then we're going to place an arrow on 12, and we're going to go back 3 1/2 spaces, and we get the answer 8.5. So you can bring that down here on this number line if you'd like, but that's the model right there. Exercise 2. Find the following sum by using a number line diagram. Negative 2 1/2 plus 5. Okay, so let's try this. The first vector is going to be 2 1/2 to the left, because it's negative. So it's negative 2 1/2. Alright, now I need to go 5 to the right. I really like this strategy of decomposing. How many spaces do I need to go to get back to 0? Well, I need to go 2 1/2 to get back to 0. Which means I will have an additional 2 1/2 left. 2 1/2 and 2 1/2, that's 5 spaces. This got me back to 0. I have 2 1/2 left, so this arrow should be, yeah, the vector ends at 2 1/2. Maybe you'd like to think about it this way. You can also think about it if you wanted to break this vector up in, well, let me show you that on a different example. I've got some other examples we can look at. Okay, example 2. Find the following difference and represent it on a number line. 1 minus 2 1/4. Okay, so we want to rewrite all subtraction as addition. That's where we're at in our 7th grade math right now. So I want to rewrite this as 1 plus negative 2 1/4. And the reason is now I have two vectors. I have a positive vector and a negative vector, and I can just add them together. I'm not removing vectors. That would be harder than it needs to be. So let's just go 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, the first vector is a 1, so it is 1 space to the right. 1. The second vector is negative 2 1/4. So here I'm going to model this differently. Because this is a mixed number, I'm going to go -2. So 2 spaces to the left, and then an additional 1/4 to the left. And that gives me a vector of -2 and 1/4. And I can look here and see, where is this at? It's going to be at -1 and 1/4. That would be my answer. Okay, so maybe you want to think about decomposing this in terms of creating an additive inverse, or creating 0. So you would go 1 to the left and then an additional 1 1/4 to the left. Or maybe you want to think about this as, I'm going to deal with my whole numbers, 1 to the right, 2 to the left, and then I have this additional fraction to worry about. So I'm going to go another 1/4 to the left. It's two different ways to think about it, but you're doing the same operations. You're just adding them and just really kind of breaking down the numbers in the way that makes the most sense to you. Okay, exercise 3. -5 5/10 minus -8. This is where we see whether or not you've really been paying attention. Because -5 5/10, if I change this subtraction to addition, I have to add the opposite, which means -8 becomes +8. Remember that whole discussion? If I take away a negative, my value increases, right? So if I'm subtracting -8, I'm actually increasing by 8. I'm taking away a negative. All right, we've changed it to addition, so now let's draw two vectors. -5 1/2, and then I can draw this vector back. And again, we think about this a couple different ways, but the way that makes the most sense to me is I need to go 5 1/2 spaces to get back to 0, and then I need to go an additional, if I go 2 spaces, that's 7 1/2, and then if I go another half space, that would be 8. So I need to go 2 1/2, and that's going to be my answer, 2.5, 2 5/10. All right, let's check out number 6. We're just going to keep mowing through these. They're all pretty much the same type of problems. So we're just, I've modeled some different thought processes, so let's just check them out. We don't need to rewrite this. It's already addition. So -6 would be 6 to the left. And 5 1/4 means I'm going to go 5 to the right. That puts me at -1. Now, I need to go another 1/4 to the right. That's going to put me at somewhere between -1 and 0. If I take away a fourth from -1, or I guess really I'm adding a fourth to -1, that's -3/4. Okay? Seeing this on the number line is important because what I will see as the greatest misconception here is that if we did something like -6 plus 5 1/4, the answer that the most common wrong answer is going to be like 1 and 1/4. -6 plus 5 is 1 and then a fourth. That's the most common wrong answer, not correct. Because when I add 5, that gets me back to -1. I need to then add that 1/4. So I'm cutting into that -1. I'm breaking off a piece of that -1. We're really adding a piece to that -1. So it's becoming -3/4. All right, and you can see that it's between 0 and -1. I think that's the key here, is looking on this number line and seeing that it's between those two values. All right, let's do the next one. Oh, here's another one where we have subtraction, and we're subtracting a negative, so that becomes subtracting becomes addition by adding the opposite of -9/10, which is +9/10. So I'm just going to go 7 to the right, and then I'm just going to go 9/10 to the right. So not even a full space, just 9/10, and that's going to put me at 7.9. All right, C. It's addition already. We don't need to rewrite it. Let's go 2 1/2 spaces to the right, 2.5, and we need to go 1/2 space to the left. Now, what's key on this, some of us know this. You probably know this. You're probably watching this. You say, oh yeah, that's 0.5. That's 1/2 as a fraction. And you're probably looking at this and you're saying -1/2. That's -5/10. We need to be talking about this in the same terms. So if you are looking at a decimal, you need to, and a fraction, you need to choose. Do I want to convert fraction to decimal or decimal to fraction? Because we need to look at this in the same terms. Okay? So I like probably going to fraction is easier. So 2 and 5/10 is literally 2 and 5/10. Right? Hope that didn't hurt your brain. 2 and 5/10. This is literally, if this is 5/10, we write it as 5/10. Okay? It simplifies to 2 and 1/2. That's equivalent. And here we are, 2 and 1/2. This is negative 1/2, so let's go back 1/2 this direction, and we are at 2. All right, so make sure, I'm going to put a star here, use the same, I'm at a loss for words here. I'm going to say like form, either fraction or decimal, like they need to be in the same form. You want them in fraction form, put them in fraction form. You want them in decimal form, put them in decimal form. They need to be the same. All right. Okay. Let's do the next one. Negative 1/4 plus 4. All right, so this is a difficult one again. This is one of those where we might get the fraction piece wrong if we're not careful. Okay, so I'm going 1/4 to the left. Now, when I go 4 to the right, am I going to be able to make it to 4? Well, if I started at 0, I would make it to 4, but I'm starting to the left of 0, so this is going to have to finish to the left of 4. Like 4 spaces will not get me to 4 because I'm not starting from 0. So if I was to go 4 spaces to the left, we can think about this as I had to go 1/4 to get back to 0. Then I went an additional 3/4 and an additional 3. So 3 and 3/4 here in addition to the original 1/4 that I did here. So that's going to give me a vector of 4. So I finish at 3 and 3/4. All right, 1/2 minus a negative 3. So this is subtraction. We need to change that to addition. And the opposite of negative 3 is going to be positive 3. Go 1/2 to the right, and then go an additional 3 spaces to the right, and that would put me at 3 1/2. It's pretty easy, right? 3 plus 1/2 is 3 1/2. Okay, let's check down here, exercise 5. We've got some word problems. Really the same thing, we're just trying to take context. So the most important thing that you're going to need to look for in these word problems is what are the integers that we're dealing with. So I would underline, I would highlight, I would circle, I would make sure I identify what my or not integers, rational numbers in this case, what they are. So Samantha owes her father $7. Owes $7. How do I represent that? Negative 7. She got paid $5.50. How do I represent that? Positive $5.50. All right, let's check this out. How much money does she still owe her dad? 1, 2, 3, 4, 5, 6, 7. So I'm going to go 7 spaces to the left. That gets me to negative 7. Now I need to go 5 1/2 spaces back to the right. So if I go 5 spaces to the right, that gets me to negative 2. And then I need to go another half a space, and that's going to put me right in between negative 1 and negative 2, which means she's going to owe a negative 150, which if we were to convert that back to language, that means she owes $1.50. All right, let's go to the next one. At the start of a trip, a car's gas tank contains 12 gallons. That sounds like a positive 12 to me. During the trip, the car consumes, it uses it up. That means that's going to be a negative value. That gas is going away. So plus negative 10 and 1/8. Let's throw that on a number line. Put 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10, 8, 4, 2. Okay. If I go 12 to the right, that represents the 12 gallons that existed. that were already contained in there already. And then I need to go 10 and 1/8